Welcome to solverfy.
So we must find the spring constant and the total amount of energy associated with the system. For part A, we know that the angular velocity is going to be equal to the square root of the spring constant divided by m, the mass. We can solve for the spring constant. This is going to be equal to omega squared times m, and we know that omega is equaling 2 pi times the frequency. Therefore, the spring constant will be equal to 4 pi squared times the frequency squared times the mass. This will be equal to 4 pi squared times the frequency of 3 hertz squared times the mass of 0.24 kilograms. And we have the spring constant of 85.3 newtons per meter. So this would be your answer for part A. And then for part B, when they want the total amount of energy, the total amount of energy associated with the system would be equal to the maximum potential energy. And this would be equal to the maximum potential energy of a spring, or 1/2 times K A squared. And this will be equal to 1/2 times 85.27 newtons per meter. And then times the amplitude of 0.045 meters, quantity squared. And we have that the total amount of energy is equaling 8.63 times 10 to the negative second joules. And this would be our final answer for part B. That is the end of the solution. Thank you for watching.